So I'm going to explain Euler's method, where we use tangent lines to approximate the y values of the graph. So for this question, we have to decide on a step size first, which is 0.1. And then we start from x equals to 0, y equals to 1. So for example, we start at x equals to 0, y equals to 1. We draw a tangent line until 0.1, and we find the increase of y of the tangent from x equals to 0 to x equals to 0.1, which is this. And then at x equals to 0.1, we draw a new tangent until 0.2 and find the increase of y from 0.1 to 0.2, which is this. And then we do this so on and so forth until we find the y value at x equals to 1. So we know that the gradient of the tangent at any point equals to the rise over the run, and we know that our run is the step size. And the equation of the gradient is dy over dx. So to find the increase of y, or the run, or the rise, we use dy over dx times our step size. So for this question, the increase of y equals to x over y squared times 0.1. So to find the equation of y, or the next y, we use the previous y value plus our increase in y, which is 0.1 times x over y squared for this question. So first we have to decide on the step size, which will be 0.1. And then we will create a table for the amount of steps taken, which will be 10, as we are trying to find the amount of the value of y at x equals to 1, and we're starting from x equals to 0. So we know that the value of x equals to the step size times amount of steps taken. So this will be the amount of steps times step size, which is 0.1. And we'll apply this formula for all the way until step 10. And then to find the y value, we have to take the previous y plus the increase in y, and we're given that when x equals to 0, y equals to 1. So we take the previous y plus the increase in y, which should be the step size of 0.1 times dy over dx, which will be our x over y squared. And this will give us our new y. So we apply this and we get the answer. Now I'm going to use the general solution to solve the question. We're given that dy over dx equals to x over y squared, which will give us integrate y squared equals to integrate x, which will give us this equation. And we bring the cube over, we get y equals to cube root equals to 3x squared over 2 plus c. And to find c, we just substitute x equals to 0, y equals to 1, which is given in the question. And this will give us c equals to 1, which will give us a final equation of y equals to cube root 3x squared over 2 plus 1. And when we sub in x equals to 1 to find the answer, we get y equals to 1.357, which is slightly different from our Euler's method answer. And this is because our step size might be too big, and the tangent line might not accurately display the increase in gradient of the graph.